Hi, my name is Matthew McGregor, and today we're going to be talking about the production and popularity of the biofuel ethanol. So, ethanol is a product of alcoholic fermentation. It's one of the most common forms of biofuel in the world, and it is a blending agent for gasoline. And there are three types of blendings or blends for ethanol and gasoline. There's E10, which is the most common. It's 10% ethanol, 90% gasoline. There's also E15 and E85, which E85 is about 83% ethanol. And it is used in flexible fuel cars as is more efficient than E10. Ethanol is grown from biomass feedstocks that are transported to ethanol production facilities to be transformed into liquid byproducts. There are two types of feedstocks. There's sugar and starch based, which is the most common. This is where you get corn and soybeans and stuff like that. There's also cellulosic ethanol feedstocks, which are plant residues. They utilize plant residues and also wood residues. Um, these are kind of have their advantages that we'll go over later, at least for cellulosic ethanol. So how is ethanol produced? There are two different types of production based on how the ethanol was cultivated. For sugar and starch-based ethanol, they're usually converted into ethanol in no, sugar and starch bases such as corn are usually converted to ethanol in dry mills. And these dry mills grind corn into flour and then use fermentation to produce ethanol with a byproduct of CO2. Cellulosic ethanol actually has two different ways that it can produce the ethanol from plant residues and wood residues. The first is biochemical, and this is where plant and wood residues undergo hydrolysis to break down cellulose into sugars. And then these sugars undergo, as we've talked about, alcoholic fermentation to produce ethanol, and then also the byproduct of lignin, which we'll come back to. And then thermochemical is simply just adding heat and chemicals to a biomass feedstock to produce syngas, which is a combination of carbon monoxide and hydrogen, and this can be reformed into an ethanol using a catalyst. So what are the effects of ethanol on the carbon footprint? To be frank, it produces a lot of carbon emissions from the transportation, the production of ethanol. It is a very high energy process that utilizes trains, cars, factories, just anything that produces you think of that can produce carbon emissions. It does. And then there's also alcoholic fermentation, which deals with releases CO2 as a byproduct. But biofuels such as cellulosic ethanol can be produced on land with low agricultural value. And this can make it more accessible and widespread, which is also better because it doesn't require as many pesticides to fertilize it. And then there's also E85, which we talked about is 83% ethanol content. And this can burn cleaner and leave no residue, which would probably be a safer bet than E10 blend of ethanol and gasoline. This can create fewer emissions and cleaner air. So the economy of ethanol has been booming. I mean, from 1981 to 2019, the production of ethanol, as you can see, has gone way up. In 2020, ethanol generated $35 billion in gross domestic product and $19 billion in household income. That is insane. It is a huge part of the economy, especially in the Midwest. So the biggest effort for communication regarding ethanol for public use was the 1990 Clean Air Act. This act was heavily supported by Congress, and it helped to create a larger market for ethanol in an effort to decrease oil imports and kind of help with those carbon emissions, reducing carbon emissions in the air. So the big takeaways from the research done was that non-food feedstocks utilized in cellulosic ethanol production are the most environmentally and economically efficient sources of ethanol production. Plant residues are in abundance and they're not edible like corn is. And thus, cellulosic ethanol can have a never-ending supply, basically, because they can be produced on land that is unable to support other productions of food, like we talked about corn. And they do not require as much fertilizer, pesticides, or energy input as corn, which can have greater environmental impacts because they don't require as much. And then the lignin that is produced as a byproduct of cellulosic production can actually be used to power the process in the first place. So the byproduct can be used to power the entire thing, which is kind of cool. So while cellulosic ethanol production does require high transport energy, more complex facilities, and a higher demand for labor, it has a positive net energy balance, which means that it produces more energy than it needs, or it consumes more energy than or it produces more energy than it consumes. My apologies. So it has a higher positive net energy balance than starch and sugar-based ethanol production, and it is more efficient in the long run. More resources should be devoted to the cellulosic production of ethanol in order to create higher yields without dipping into a source of food such as corn. So the plan of action, cellulosic and E85, that's what I'm talking about. If funding were not an issue, it is my strong belief that the government should install positive regulations regarding the production and transportation of cellulosic ethanol in order to gradually transfer resources over time from sugar and starch-based ethanol production into more sustainable options of cellulosic ethanol production. Furthermore, the government should set goals to reach regarding the increased production of flexible fuel cars, which utilize the E85 concentration of ethanol and gasoline. Flexible fuel cars would reduce carbon emissions on the road and provide a more sustainable alternative to most cars that usually run on the E10 blend. Here are my citations. Thank you so much.